Hi, so your first job was to complete the Mixed Review 6 on the other side of this note sheet. And now we're going to start just a review of the geometric figures that you'll see on this side of the note sheet. And then tomorrow in class, we'll finish up with the notes of the more complicated geometric figures and angle relationships. So I'm just going to have you labeling a few things on these notes. The point A, the definition of a point is an exact location named with a capital letter. If you have to write it, though, you need to make sure that you're using the word point. So if you could just add this on your notes, you have to write the words point A. So any point is an exact location, and it's always named with a capital letter. For a line is a straight path that extends without end in opposite directions. A line is named by 2 points on that line. So this line, we would call it line EG. And you could write the words line EG, but a faster way to do it, and a symbol that represents the word line, you put the E and the G together, and then you draw a line with the arrows on the end to represent line EG. You could also call this line GE and flip-flop the 2 points on the line. It doesn't matter which way you go, since the line extends without end either way. A plane is a flat surface that extends infinitely in all directions. It's named by 3 points on the plane that are not on one line. So this plane, if I were to draw lines in, I'd need to make sure that these 3 points, A, B, C, are not on the same line. So we're going to name this plane, and you have to write out the word A, B, C. Again, if you wanted to mix up the letters, you sure could. So you could call this BCA, or CBA, or CAB, or any of those, but there's no abbreviation for plane. If you can see in the picture, it says ABC in the corner. They're naming that plane. So a plane is just a flat surface. A ray is a part of a line that has one endpoint and extends without end in the opposite direction. A ray is always named by the endpoint first, then another point on the ray. So this is when you can't flip-flop the letters around. We can write ray as CD. Let's put that together, and then we draw a ray, but it only has one arrow on the end. And if you wanted to put the dot on this end, you sure could. We can't flip-flop the letters around and name it ray DC, because then that would say that it's starting here and going in that direction, and it is not. A line segment is a part of a line or array that is made up of 2 endpoints. As you can see here, it's named by its 2 endpoints. So this we could call PQ, or you could call it QP. And the symbol for a line segment, you could just draw this above the top of it. If you want to put the little dots on the end to symbolize line segment, that would also work. So just a review of those geometric figures and ways that you can write them. Moving down into the angle review, I'm going to need you guys to fill in some notes on here. Right angle is an angle that measures exactly 90 degrees. The square corner symbol indicates a right angle. So in the picture, I'm going to have you name this angle. So we're going to name these points. Please write in A. Let's put B at the vertex and C here. And then the symbol for angle, it looks like a little angle symbol like this, and you write ABC. Another way you could name this angle would be angle CBA. But you always have to have the vertex, which is the point between the 2 rays that they meet at. That has to be in the center. So we couldn't call this angle CAB because A is not the vertex of the angle. An acute angle is an angle that measures less than 90 degrees. Let's call this angle TNY. So put your angle symbol TNY. You could also call it YNT. I did TNY for tiny because an acute angle measures less than 90 degrees. An obtuse angle is an angle that measures more than 90 degrees, but it's less than 180 degrees. So this one we called angle BIG. For big, so it's a bigger angle. You could also call it angle GIB if you wanted to, as long as you keep the I, which is at the vertex of the angle, in the center when you name it. The straight angle is an angle that measures exactly 180 degrees. This looks like a line. So let's just call it, how about LNE? So angle LNE for line, or angle ENL would work too. Okay. Moving down on your chart, these are the two angles that we're going to finish up with. Complementary angles. I think you've heard of them before. It's where you add two angles together and the measures add up to 90 degrees. So it says if the sum of the measures of two angles is 90 degrees, then the angles are complementary angles. So in the picture, you'll notice we've got two angles that are together here. Angle LMP is this big 90-degree angle, but it's split up into two angles with this ray coming out, ray MN. So we've got a 65-degree angle plus a 25-degree angle, and 65 plus 25 is 90. So if you were going to write it, you'd want to write that angle, let's put it over here, angle LMN and angle NMP are complementary. Now, sometimes kids get stuck on this because they think the angles have to be touching like this, or adjacent, they're called. And that's not true. So I have another picture here where there's a 60-degree angle off by itself and a 30-degree angle off by itself. And I want you to understand that complementary angles are any two angles. I don't care where they are in the picture. They have to add up to 90 degrees, okay? A little trick we use, or a little line we use to remember that complementary adds up to 90 degrees. Since a 90-degree angle is also called a right angle, if you remember a compliment, which is a nice comment that you give someone else, a compliment is the right thing to do. So complementary angles add up to 90 degrees because of the right angle, okay? Supplementary angles. If the sum of the measures of two angles is 180 degrees, then the angles are supplementary angles. So now we're adding two angles again, and they have to add up to 180 degrees. So if you take a look at our picture here, I've got angle GHK, which measures 65 degrees, and then I've got angle KHJ, which measures 115 degrees. When you add those two together, you get 180 degrees. So this is an example of supplementary angles. Now you also maybe want to just take a look at this. Do you see how this straight angle right here, GHJ, you know that's 180 degrees. So if you ever see a straight angle and you notice it's split into two separate angles, you would know those two are supplementary angles because they would have to add up to 180 to create this angle right here. So let's go ahead and write that down, that angle GHK and angle KHJ are supplementary. Okay. Now, two other things I'm just going to ask you quick to do with me right away. If I tell you I have a 70-degree angle, and I ask you to give me its complement. So if I say angle equals 70 degrees, and I say, what is its complement? You would need to know the complement would be where you take 90 degrees and subtract the 70 degrees. So let's fill in the complement for this. We'd say, let's just show our work, 90 minus 70. So we know the complement is a 20-degree angle. And angles are always labeled or measured in degrees, so make sure you put your degree sign there, okay? So let's try a supplementary one. If I say the angle equals 80 degrees, and I want its supplement, let's put a little question mark there, you would want to take that 180 degrees and subtract the 80 that you know to see what's left over. So we know we'd have a 100-degree angle would be its supplement, okay? You can stop here in the notes packet. The second page we're going to go over in class tomorrow, and that's leading into a little bit more with lines and angle relationships. So this was just a quick review of some geometric figures and angles that you've learned in previous years. And make sure you have your mixed review done and entered into Schoology for tomorrow. Thanks.